Hey students, on this video, we're going to go over the notes for difference of perfect squares and also the sum and difference of cubes. So there's going to be two parts for this notes. Difference of perfect squares is going to be part 1, and sum and difference of cubes will be part 2. All right, so for the difference of perfect squares, first of all, you need to know what a perfect square is. If you recall from earlier mathematical levels, squares, it's pretty much they're the same side. So 2 and 2, 3 and 3, 4 and 4. They create an area by multiplying, so 4 will be the area. That creates a perfect square. 4 is considered a number that is a perfect square. So if you think about replacing that number with 3, then you're going to have 9, because 3 times 3 is 9. And then 4, you're going to have 4 times 4 is 16. So it creates a pattern of numbers that are called perfect squares. So you're supposed to by now already know at the top of your head what these numbers are. Just thinking to yourself, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25. So at least push yourself to memorize these numbers all the way, why not all the way to 15? So that way you can just have them in your mind, just like that, super fast. You can recognize them whenever you see them. And I'll just keep going if needed, but for now, just know that these are all perfect squares. So you're going to look at the binomial that you have, and you're going to ask yourself if what you have in the beginning and at the end, if both of those are perfect squares. If they are, and there's a minus between it, then it's difference of perfect squares. And this pattern applies, where you can immediately write two binomials with the square root of the first one here, because this number times this number is that, and then the square root of this second one in the other end of the binomial. So I'm going to go over two examples real quick, but first I want to go over an example of Algebra 1 level, because you saw this in Algebra 1. Excuse me. So you may have seen something like this. And this is technically a trinomial that has a 0x, a 0b value. When that is 0, that means that you combined two numbers that were the same, a positive and a negative, and they cancel each other. And that's why you have a 0, and that's why there's no middle term. So you need to remember that these numbers are created from a combination of a times c. So what two numbers do you multiply to get -9 and then combine to get a 0? So that's like +3 and -3, which means you will have x plus 3 and x minus 3 as your binomials. X times x is x squared. X times -3 is -3x. 3 times x is +3x. And then that -9 is from 3 times -3. So you're supposed to go from here to here immediately. Just like you think of 2 times 5 is 10, immediately, you need to look at this perfect squares and difference of perfect squares and immediately know, oh, I can rewrite it as two binomials. The square root of x squared is x, so x times x is x squared, and the square root of 9 is 3, so 3 times 3 is 9. And then there's no middle term, so that means one's a plus and one's a minus. And also, in order to get a negative value, when you multiply these, one has to be a positive, one has to be a negative. So this mindset goes behind these two examples right here. So the first example is going to be looking at what do I have as a GCF? So you always want to ask yourself first, is there a GCF? So 9 and 36. 9 can be divisible by 9, 3, and 1. 36 can be divisible by 9, 4, 6, 12, 3, a lot of them, but definitely they both have number 9 in common. Sorry for the bell, just recording while I'm in school. So 9 can be divisible, both of these can be divisible by 9. Now, as far as the letters, the variable p, the highest that you can take out from both of these is 5, because this one has 7 and this one has 5. So if I remove 5 from here, I can also remove 5 from here. So now I'm going to do 9 times what gives me 9, so just 1. P to the 5th power times what gives you p to the 7th power. So that's where you kind of write p squared. And this 1 doesn't need to be here, because anytime in algebra we have a 1 as a coefficient, we don't see it. So don't worry about that one. So we're going to have p squared minus, and then 36 divided by 9, that's 4. P to the 5th power divided by p to the 5th power is just 4. It's just by itself. So that's the GCF. This is the binomial that's left. This binomial is a difference of perfect square, because you can immediately see this p squared and know that p times p is p squared. 4 can be found with 2 times 2. And in order to get that difference, one's a plus, one's a minus. And then just bring down your initial GCF that you took out. And that's the answer for this. That's the rewritten version of this binomial. Let's do that one more time. So we're going to look at it and ask yourself, is there a GCF? 81 and 16. I believe 3 is one number you can divide by, but I'll double check. Yes, so we can divide 3. Oh, actually 16 cannot be divided by 3. So never mind. Let's see. They're not even numbers. No. So no, there's no GCF. What you're going to do next is just proceed with the pattern of over here. You're going to look at the binomial as, can I have something times itself be that answer? So you're going to look at 81, thinking of square root of 81. So 9 times 9. And then x to the 4th, you kind of cut that in half because it multiplies times itself. So you're just going to do x squared. Then you think about the 16, and that's 4 times 4. And then that's where you just put a plus and a minus. So this will be the answer to the perfect squares, difference of perfect squares. Okay? Hope this video helps you understand that.